Graphing radical functions. To understand how to graph a square root function, we have to first understand and recall what a parent function is. A parent function is that basic function that we use to graph quickly and graph by hand. Okay, so the parent function of a square root equation is y equals the square root of x. So that is the parent function. Now if we were to graph it, we would graph it at the point 0, 0, and then it's going to go through the point 1, 1, and it's going to go through the point 4, 2, and it's going to go through the point 9, 3, and it's going to continue like that. So this is my parent function of the graph. So as you are identifying how to move it, you're going to be graphing the points right there. So you're going to have to remember the points 0, 0, 1, 1, 4, 2, and 9, 3. You have to remember those points, and those are the points you're going to translate. And you're just going to translate those points to get your new function. For this first example, we want to graph the equation y equals the square root of x plus 2. Okay, so we need to remember that if we are adding 2 on the outside of what is happening, then it's going to go up that number of spaces. So we're going to translate up 2. So now I go back to my original parent function points, 0, 0, 1, 1, 4, 2, and 9, 3. That's my parent function. And then I'm going to go up 2. So I'm going to shift every point up 2 spots. And then I'm going to connect the dots. So that is my final. And that's it. For this next equation, we have y equals the square root of x minus 1. Okay, so we're looking at a minus 1 on the outside of the square root. So that's going to mean we're going to go down 1. Because it's on the outside, we're going to change the y. So I'm going to take my parent function, the key points, 0, 0, 1, 1, 4, 2, and 9, 3. And I'm going to shift all of those down 1 spot. And then draw my line, and that's your final answer. For this third example, we have the y equals the square root of x plus 2, where everything is under the square root. So that means the plus 2 is in there with the x, so it's going to go left or right. When it is plus, we're going to go left 2 spots. Okay, so I'm going to go back to my original key points on my parent function. 0, 0, 1, 1, 4, 2, and 9, 3. And then I'm going to go left 2 spots. And then I draw my line. So that would be my final answer. For this fourth example, we have y equals the square root of x minus 3. This time again, the minus 3 is under the square root, so that means it's going to go left or right. And the minus is going to tell me that it's going to go right 3 spaces. Okay, so I take my key points, 0, 0, 1, 1, 4, 2, and 9, 3. And I'm going to move those right 3 spaces. So that would be your final answer. In some cases, there might be more than just one thing happening. In this next one, y equals the square root of x plus 3 minus 1. The x plus 3 is under the square root, the minus 1 is not. So I'm going to start and just work left to right. So the plus 3 is going to mean that we go left 3 spaces. The minus 1 is going to mean that we go down, because it's on the outside, 1 space. So now I'm going to take my key points here, 0, 0, 1, 1, 4, 2, 9, 3, and I'm going to move left 3, down 1, left 3, down 1, and so on. Then I'm going to connect those points. And that's your final answer. Okay, and this last example of this type, y equals the square root of x minus 4 plus 5. So we look at the minus 4 is inside under the square root, so that's going to mean we go right 4 spots, and the plus 5 that is on the outside is going to mean that we're going to go up 5. So I'm going to look at my parent function, 0, 0, 1, 1, 2, 4, 4, 2, sorry, and 9, 3. And then we're going to go right 4 and up 5. About like that. Then you draw your line. And that would be your final answer. For this next example, we're going to use a different method. We're going to solve by using a table. Okay, so when we're using a table, remember we pick some values to see what's going to happen. Okay, so I'm going to pick some values for x. If I pick 0 for x, then I'm going to put 0 in, so I'm going to have the square root of 3 times 0 minus 1, which is going to give me a negative 1. So my y value is negative 1, so I have 0, negative 1. Now my next point, if I choose 1, then I'm going to have the square root of 3 times 1 minus 1 is going to equal 0.73, or roughly that. So that's going to be about right here. If I use 2, then I'm going to have the square root of 3 times 2, which is 6, minus 1, which will give me 1.45. So 1.45 would be about right here. Then if I choose 3, I'll get the square root of 3 times 3 minus 1. So when we solve that, we have the square root of 9, which is 3, minus 1, so we get 2. So at 3, I'm going up to 2. So then I probably have enough points to kind of graph what I'm doing. I know it's a curve, and it's going to go like that, roughly. So something like that. As long as you kind of get the idea, then that's how your graph's going to go. Just pick some points, plot the points, and there you go. For these last two examples, we're going to be finding the domain of radical equations. Domain of radicals are interesting because all you have to do is take whatever the radical is and set it greater than or equal to 0. Okay, because you can't have a negative square root. So I'm just going to take the inside, 3x minus 9, and set that greater than or equal to 0, and then just solve for x. So I'm going to add 9, giving me 3x is greater than or equal to 9. Then I divide by 3, and x is greater than or equal to 3. So I know that I can't put 0 in for x because x has to be bigger than 3. So that's how you find your domain. So for this next example, I'm going to set the inside greater than or equal to 0. So that's going to give me negative 2x plus 5 is greater than or equal to 0. So I'm going to subtract the 5 from both sides, leaving me 2x, negative 2x is greater than or equal to negative 5. Then I have to divide by a negative number, negative 2. But when I divide by a negative, I have to flip my inequality symbol. So that's going to leave me with x is less than or equal to double negative, flips to a positive, 5 halves. So x has to be bigger than 2.5, or 5 halves. Those are your notes over graphing radical functions. Go through some practice problems, then you should be ready for your quiz over this material.